Losing my pens. Hello world. We're gonna, oh gosh, wrong button. Happens. Technical difficulties right off the bat. There we go. All right. So let's take a look at trapezoids. What is a trapezoid?
It's a truncated triangle.
It's a truncated triangle. That's awesome. And if we truncate a triangle, we're going to get a four-sided figure. And, ooh, that's a good point. Is it any old truncated triangle? Huh.
Don't make it more confusing than it has to be.
Yeah, Gary.
Jackie started.
It could be a truncated triangle.
It could be a truncated triangle, yeah. So let's see. If this were my triangle here, there, and here. It depends on how I truncate it. Oh, I didn't want it to be so nice. Shorter maybe. You, come on, man. Oh, whoa! I didn't do that.
Oh.
I think you should learn by. As it keeps going.
As you keep. There you
There we
go.
go. Okay, so here's my triangle. So let's pick a different color. Line tool. So if I truncate at some angle like that, then this figure I get after the truncation is a quadrilateral, but it's not a trapezoid because
It doesn't have a set of parallel.
it doesn't have a set of parallel sides. Yeah. So to fix that, what we want then is to make, there we go. Make this parallel that truncation to one of the sides. So now I'm trying to be parallel to the bottom side. So I have this new, pull you up, yes, goodbye, yes, oh gosh, there we go, goodbye. All right, try it again. So now I have this shape right here, and that truncated triangle is definitely a, call it a trapezoid. Okay, so let's see. Is there a trapezoid tool here? I can draw a rectangle, an ellipse, a triangle, a hexagon, a pentagon. Oh, it doesn't let me draw whatever kind of shape I want. Okay, so I'm going to switch over to GeoGebra, I think, to do this drawing. GeoGebra is my favorite app lately. All right, so here's my GeoGebra screen. I'm just going to move that out of the way. Switch to the polygon tool. Polygon tool. There it is, polygon. All right, so here we go. Click. And how about click? And then we'll come up here maybe. And then how about right there? All right, so here is my trapezoid, GeoGebra style. Screenshot that page. All right, so I want to find the area of this thing. Dimensions of this are 1, 2, 3, 4 across the bottom, 1 across the top. And then the other thing I could note is if I draw an altitude from the top to the bottom, it has a height of 2. That would be the height there. I could use the Pythagorean theorem to come up with these other side lengths. For example, think back to the Pythagorean theorem. Yeah, so to get that length right there, that missing side, they're calling it E. E squared would be 1 squared plus 2 squared. So let's see, what would that be? 1 plus 4, which is 5. So E would have to be the square root of 5, which earlier we thought was about 2.2-ish. Sound about right?
Mm-hmm.
So in terms of finding the area, what's more important here, the altitude or the diagonal lengths of the trapezoid? Why?
What
What do we measure area in?
Base times height,
But what units do we use to measure area?
centimeter,
And it's centimeters and inches, those are length, not area. What are our units of area?
centimeters.
Yes, area units are things like centimeter squared, inches squared, feet squared, centimeter squared. What's a centimeter square look like? It looks like a square that measures 1 centimeter by 1 centimeter. Okay. What's important about a square? Well, a square has sides that meet at right angles. So that means in order to do measurements for an area for most figures, you need measurements that are perpendicular to each other. So it's not the diagonal length that matters, it's perpendicular lengths that matter. So what we're going to do is dissect this. So I'd like you to make your best artistic rendering of this trapezoid on a piece of paper. Copy this to your screen where you get your artistic renderings going. I guess I'll do an artistic rendering of it too. All right, so here's my best artistic rendering of it. It's 4 across the bottom, and then I went up 1, 2, and over 1. So it does that right there. And then I go over 1, and then this goes up 1, 2, and over 1, 2. So here's my 1 for altitude coming down here, which you can also call the height, is 2.
And you need the 90-degree angle.
Yeah, so the 90-degree angle right there is important. So here's the dissection that we're going to make. As I measure across here, there's 1 unit, 2 units, 3 units, 4 units across. I would like you to make a vertical cut at 1 unit over, straight up. Then what we're going to do is we're going to take this chunk right here, and we're going to cut it off. And we're going to pick it up, and we're going to stick it right there.
Why would you do that?
You'll see. I have a method to this madness.
God, one of us does.
So again, what I did was I chopped this sucker off, and I stuck it up there. Cut. Oops, that's not nice. Cut. Then cut and paste. All right, so we're going to do the same thing on the other side. Okay, so the way I'm going to decide on making that cut is I'm going to consider I could have drawn an altitude right there. I'm going to go halfway in between that and the edge of the page, and I'm going to cut, so half a unit over. If you make that cut and remove this sucker right here, it's gonna, and you paste it up above, it's gonna fit perfectly right there. Now my drawing doesn't illustrate that very well because it's not the best artistic rendering.
I'm glad these are not to scale.
So that piece right there ended up right over here. So my claim is this new red shape I've built now has, let's see, what did I cut off? I cut off a whole unit down here, right?
Yeah.
I lost 1 there. And how much did I lose over
A
there?
half.
I lost 1/2 over there. So from 4, if I take off 1.5, what's left?
2.5.
2.5. So the distance across the bottom now should be 2.5 across there.
So we draw the square and put 2.5 at the bottom.
It's not a square. I know it looks like one at this point, but it's not. How high is it?
4.
No,
Oh, wait, 2.
it's too high. Okay, this is now a rectangle, agreed?
Yes.
Okay, 2.5 times 2 equals what? So this rectangle has an area of base 2.5 times 2, which on a good day is 5 squares. My claim is that's the same as the trapezoid above. The trapezoid above also has an area of 5. So we're going to find that in a couple of different ways. We already found it in one way. What's up?
Why can't you do half of the height and then do one of the numbers plus one of the numbers.
So why would you take half of the height?
Because you cut off half of the other side, so then,
Well, doesn't it still have the same height here?
I don't know, we didn't. Sure.
How high is this right here, from here to here? What's the distance from the top to the bottom?
Is it still the height of 2?
I haven't cut anything off the
Okay.
top, right? What's the height of this figure right here?
2.
Okay, so why would we take half of the height?
Because for triangles, isn't it half of base times height, and don't we make a triangle by cutting off
What are we
the
taking
ends?
half of, though?
A
That's the
trapezoid,
question.
but isn't a trapezoid made up of triangles?
Yes. Okay, we're getting there.
You just slice it and then find the rectangle in the middle and 2 triangles on the side, add them all up.
You're gonna sugar daddy and make some that's figures.
Oh, don't ever say that again.
No. You're
Okay.
gonna have a whole new set of problems. Still no
All right,
skills.
so hopefully that didn't get recorded on the internet. All right, let's see, my tools are here. So let's check out what just happened there. So what I did here by cutting off pieces at the bottom, would you agree the bottom is longer than the top?
Yeah.
So I took some of the length of the bottom and gave it to the top.
Yep.
That's average. When you share stuff,
Yeah.
that's average. Remember we talked about average means sharing?
Yeah.
Okay, so what was the base originally here?
4,
And what was the top?
1.
1. So if you take 4 plus 1 and cut it in half, isn't that the average of 4 and 1?
1 is 5.
Right.
Over 2.
Add them up,
Yeah.
divide by 2.
Uh-huh.
Okay, so 4 plus 1 is 5. What's half of 5?
3.5.
5.
2.5.
2 and a half?
2.5.
Wait a second.
Isn't that what I ended up with right there?
Yes.
Holy cannoli.
What you're saying is, you take the perimeter of the 4-sided figure.
Nope.
No.
Not taking the perimeter. All I looked here is that there were a pair of parallel sides that were
Okay.
not of the same length.
Okay.
What I did was I cut them up and repositioned things so they were the same length. In other words,
Okay.
I averaged those 2 parallel sides.
Okay. I guess what I'm trying to say is if you found the perimeter.
Yep.
And you divided that by 4, figure out, what the
That,
length of one side would be if it was a square, will
Yeah,
that be the right?
it turns out that won't work
It won't work.
because of the angles that make those sides.
Okay.
Yeah, that messes this. So you can't average out the perimeter and expect to get the same area. What you'll get is the same perimeter with a different area.
Okay,
In this case, what we're doing is we're making a figure with a different perimeter, but the same area.
okay,
We're trying to maintain area
okay,
by just cutting and removing and
Okay.
replacing stuff. Yeah. So it turns out this red figure I made will have a smaller perimeter than the original figure, but it's got the same area. Yeah. Like remember those when we were playing around with shapes of area 3?
uh-huh.
They all had different perimeters, right?
Mhm.
Yeah. So you can have the same area but a ton of different perimeters just by rearranging the area.
Okay,
Yeah, so that's what we're doing right here. So the moral of this story right here, and we'll look at other versions of it, is that when in a trapezoid, the parallel sides are referred to as the bases. And so that means either we're orienting the thing like that, or we could orient it the other way. So put the small side at the bottom. Either way.
that's another way to find the area, is put 2 of them together. And then
Yes.
cut it in
Then you
half.
make a parallelogram if you do that. So if you flip a trapezoid and stick it onto itself, you always make a parallelogram, which is kind of cool. So that'd be another way to look at it. Sarah recommended a slightly different way of looking at it. So anyway, let me get back to this and we'll look at Sarah's way and then we can look at that one. So trapezoid, parallel sides are called the bases. So my cutting it up and putting it back together, what I was doing there was I was averaging the bases. And then if you multiply the average of the bases by the height, you get the area. trapezoid. So often we'll call this, say, base 1, and this one down here is base 2, and then we have some perpendicular height that we have to measure. So the area is always base 1 plus base 2 over 2. There's my average of the bases times the height. So let's look at it a different way. Sarah said that any trapezoid can be cut diagonally to make two triangles. So let's explore that idea. So we need to redraw these figures. Let's see, to the best of my ability, I have 1, 2, 3, 4. And then I have to come up 1, 2, and over 1, and over 2. So my figure looks like that to the best of my artistic ability today. And the height is 2. So if I were to cut this into two triangles, I just need to make a diagonal. Which diagonal would you like me to draw, Sarah? The one from the lower left to the upper right, or the upper left to the lower right?
I don't know since I don't know my left and right.
Okay, so I'm going to draw this one then.
That works.
Okay, so lower left, upper right. I know I'm left-right challenged. So I have two triangles here. So I have this upper one, I'll say that's the blue triangle. What would we say its base is right there? As a base of 1. What's its height? What's the distance from its baseline to its peak? It's 2. Yeah, so this triangle right there, the blue one, has a base of 1 and a height of 2, and we cut that in half. That gives us an area of 1. Let's see, what about the red triangle? What's the red triangle's base? 4. And its height? 2. And we divide that by 2. That gives me?
4.
4. And if I add those together, shouldn't that give me the trapezoid?
5.
5, which is the same thing we did before. Now, if we break that down, saying that this is base 1 up here, and this is base 2 right there, one of the triangles was base 1 times the height over 2.
Okay.
The other triangle was base 2 times the height over 2. What do these things have in common? Well, they have a height in common, and they have a 1/2 in common. So I can factor out the height, and I can factor out the half. And what's left behind?
The bases.
The base plus the other base.
The other base.
Base 1 plus base 2. And if you look at that formula, it's got hiding within it the formula we wrote the other way. The average of the bases times the height.
So all 3 of those ways are correct.
All 3 of those ways are correct.
So just use the one you're good at.
So there's lots of different ways geometrically to play with this. All right. Next bit of fun, circles.
Ooh.
All right, so what do we know about circles?
They're round.
They are round. We know the circumference of a circle is pi times the diameter.
Yeah, they're 360 degrees and
There's 360-degree rotation.
You know that the area of a circle is pi times 2, pi times the radius.
2 times
Radius
pi
times pi
radius.
squared.
Oh, geez.
Radius times, no, pi times radius squared.
There we go.
Shit,
Pi
I was gonna
times
get
the
it
radius
eventually.
squared. Okay, gotcha. Pi times the radius squared.
You know there's 360 degrees in a circle?
So here's what we're going to do right here. I'm going to make a cute shape here, and we're going to try and find the area of this cute shape.
Well, of course we are.
Let's see if I can
That is kind of cute. It looks like one of those old cartoons with those big holes.
And you want to find the area of that shape?
An umbrella. Oh,
Yin and yang.
Yin and yang.
For
Okay.
the balance.
So we're gonna find the area of yin.
Okay.
What numbers are there?
Yeah, we
can't
need
see
some numbers there, Buster.
I actually do have some numbers hiding behind the circles there. So the center is at 0, so the radius of the big circle is 2. And the radius of the little circle, that would be 1 right there, is 1.
Okay.
And you want to find the area of
I want to find the area of yin.
So the big circle.
There's 2 ways
No,
to
you want,
find
you
it.
want to find
No, the
area
shaded
of
region.
Okay.
Yeah, shaded region. So that's my yin.
Well, you
So
should
you remember
probably-
yin and yang?
Yes.
Yeah, so this is my yin and yang shape here.
Okay.
All right, so there's a couple different ways to go about this. I'm gonna let you struggle for a minute.
Okay.
Come up with the area of yin or yang. Take your pick. Write something down on paper.
Are the circles equal sized?
Circle E and circle D, those are the little ones, they are the same size. They're both
Okay.
radius 1.
Okay.
And circle C has radius 2.
Okay.
So is circle C twice as big?
I'm still trying
Yes.
to figure out the first problem here that you
Yes.
asked about.
No,
No, it
it's
would be,
not.
it's more than twice.
It's
the
more than
size.
twice as big. Yeah. How many of, say, circle E fill up circle C?
One question at a time, like
I know,
Barry.
there's a lot of questions. Okay, Play,
I
check
lost
with each
myself.
other.
I have no idea where we're at now. I'm like,
You're still trying to find the area of
Yeah.
that shaded
Is
region.
it 4?
What's 4?
Like circle E is 1/4 of the area. Of
Oh
circle
my
C.
gosh, Jackie, you rock. Good
But
job.
why?
4, yeah, so you could either say the little circle's 1/4 of the big one, or the big one's 4 times the little one.
Because it's half the radius.
Okay, so what's the area of a circle?
Hi.
Pi r squared,
Pi r
okay?
squared.
So the big one is pi times 2 squared. 2 squared is 4, so it's whatever 4 pi is.
12.56.
About 12.56, thank you.
You're welcome.
The little one, that's supposed to be way means. Okay. The little one, let's do that in red. Oh, there we go. Is pi times 1 squared, which is pi, which is about 3.14. And 1 pi goes into 4 pi's how many times? Exactly 4 times. Yeah. So it turns out the big one is 4 times bigger than the little one. It's kind of cool. And the reason is because area squares stuff. And we grew in 2 directions. We grew that way and we grew that way. 2 times. 2 times 2 is 4. It's easier to see with squares. We looked at this a while ago, right? Consider a 1 by 1 square. All of a sudden, you decide to make that square 2 by 2. How many times bigger is it? It's 4 times bigger, right? So it's easy to see with squares. All right, so yin. Let's get back to yin here. How are we going to figure out how big yin is? There's 2. And you're the student explorer.
Get it.
Like Dora the Explorer, right?
Yeah,
We can do
that.
this. Focus. Jackie, you on this?
Yes.
Did you draw a picture of it?
Of that one?
Yes.
No.
Copy that picture down on paper to the best of your artistic ability. I'll do it too. New page. Artistic rendering. Circle. Center. Semicircle. Semicircle. Here's yin. Oops. I'm going to do the highlighter. So we'll do this the easy way, then the hard way. I'm trying to find this region right here.
So that is 1/2 the area.
That's the easy way, yeah. It's 1/2 the area of the big one because I made it very symmetric. So yin is 1/2 of the big area, which is pi times 2 squared. Well, 2 squared is 4. Half of 4 is,
2.
so it should be 2 pi. So other ways to think about this. I could have sliced off this semicircle right there and picked it up and stuck it right there, in which case, what have I built?
A half circle.
A half circle. Yeah. So you know how when we were playing around with areas on the geoboard, we were cutting and pasting stuff together? That's a lot of these puzzlers can be done that way. All right, so let's see some puzzlers we have in the homework. I wonder if they ever had any of these on the Car Talk puzzlers. You guys ever listen to Car Talk on NPR?
No.
No? Oh, you should look it up. It's awesome. Let's see, what one was this? 12? I think it was number 12. Oh, there it is. This is a beauty. Okay. Let's see if I can blow this up. Not really. But if I go to the print version, I think it'll be the same pictures, maybe different numbers possibly. All right, just the print version. Oh yeah, that's a little better. So let's see, we just did part C. And can I scroll? Oh, too big. Ooh, this one's fun right here. D. I challenge you to do D. D is the hardest of the bunch. Okay. Play, cut, paste, chop. Put it back together. Find D
Don't we have
somehow.
to solve A, B, and C first before
Ah.
we get to D?
Why?
Because that's the
Oh.
order it gives us on our homework.
Well, that's okay. I wouldn't worry about that. We just did C. Right? Isn't that yin?
Yeah.
Or I guess yang now.
Either or, yes,
No.
there's no.
We got the ice cream cone, and we got the googly eyes.
So we just have to do it with the pie part.
Yeah,
we
so
don't
these are hard, right? This is big circle minus 2 little circles. No problem. Half a circle plus that triangle. Right? You can totally do that. D is the only hard one here. So, what should you do first?
phone a friend.
Did someone say draw it? Oh my gosh, that's an excellent idea. You should draw for yourself on paper. That's a good start.
Do all of those, oh, I see it. All of those pieces make up one circle with a radius
Ooh,
of
do they?
5. We'll kind of look at, if you look at it from corner to corner, it makes a half circle from each corner. Does that make sense?
I don't quite see half circles there, but I do see circular arcs. So let me copy that into my board and I will try to draw on it. That's a pretty good yin there.
That is.
All right.
Did a good job with that one,
Thank you.
Gary.
You were smart by wearing your yin yang shirt today then.
Oh my god! Oh my gosh! I
You
didn't
did.
realize I have my yin yang shirt on. My friend designed this.
Like,
Very talented.
can I explain what I mean?
Yes. Let me copy this. I lost my copy and paste button. Here, back here. There you are.
Oh, no, there would be a little bit of a white space in the middle, maybe. Oh, no,
Okay.
I don't know.
So here's what we got. All right. So the arcs drawn here. So if I say cut this up like that, this right here is the arc of a quarter circle. And so this right here is also the arc of a quarter circle. So there's several ways to go
So
about
there's
doing
4
this.
quarter circles, so they.
Well, I don't have the whole quarter circle, right, because I'm missing this part right here is
yeah.
missing.
So is it a quarter of a quarter?
Write something down. It's awesome that you're coming up with all these ideas in your head, but put some of it on paper to brain, because how do you troubleshoot what's in your head? It's hard. Put it on paper, it's easier to troubleshoot. Step 1, draw this picture. Do it now, draw the picture. Come on, stop resisting. I can't do it without drawing a picture. I'll do my best artistic rendering on the next screen. All right,
And you're trying to find the area of the shaded version.
I'm trying to find the shaded region, yeah. So I get this big old square.
That's 10 centimeters by 10 centimeters.
And the big old square is kind of cut into quarters.
Uh-huh.
And let's see, 10 is the total. So that means, so this is 10.
10.
So this part right here is 5. And then I have these circular arcs. So
Oh, yeah.
semicircle, semicircle, semicircle. Oh, shit.
Other direction there, Gary.
Damn, you're all excited.
That's
Alright, there we go. Semicircle, 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 no. Quarter
Yes,
circle.
quarter circle.
Quarter circle.
You could find the length of the quarter circle with a triangle.
Okay, but we're not looking for length, we're looking for area. And do I know the radii of each of these quarter circles?
Yeah. No. Yes. No.
So this would be the center of one of those circles right there,
Right.
and the radius would be that distance or that distance.
5.
Which is
Which
5,
we've already
yeah.
determined
So
is
every
5.
one of these has a radius of 5, so that's cool.
Oh, right, because you have to look at it as a whole circle,
Yeah,
not just
and,
as a
and,
little
if,
chunk.
and
Okay.
as far as semicircles go, the semicircle would be all of this area, but unfortunately, we don't want that part right there.
Can't you just,
We gotta remove,
Can't you just-
remove that.
can't you just stick it in the formula we did before for area? Where it's the pi, I'm writing it down.
Right, set it down. So let's see, we know that the area of a circle is pi r squared.
Yeah.
But we have chunks of quarter circle, but we don't have the whole quarter circle. We have part of the quarter circle.
But you could make the whole quarter circle if you.
I could make, so the whole
Good.
quarter circle would be, let's see, what do I have, 5? So that
Yeah.
would be pi times 25 over 4.
Uh-huh.
That would be that blue area I have,
Uh-huh.
but I don't want that red area. How do I find that
Subtract
red
it
area? Subtract what out? From what? We're trying to subtract some square chunk out. How do, square?
Why can't you do the area of the
Square, oh
square
my gosh,
first,
do we need
base
the
times
area of the
height?
square here? Oh, okay, keep playing, figure it out.
Of the whole square.
Write something down.
Of the little.
Do you need a piece of paper, my dear?
Sure.
Yeah, piece of paper right there. All right. Okay, so we're gonna have a moment of silence while we all write things down. Hopefully you people in the future are writing stuff down. Calculator out.
Hello,
We're having fun
we're
here.
having fun. She's keeping me in line.
We're doing
We're
math.
trying to find that area right there.
Yeah.
My math. Yeah.
Without calculus.
How
Yes.
calculus,
Yeah.
correct.
Yeah, I
yes.
keep going.
We
well,
just found
took-
yin.
Yeah. No.
We found the
You
area
want
of
to do
the
calculus.
Now we're trying to find the area of that particular flowery thing. Getting close, we have lots of good ideas.
Do you want a piece of paper, Mom?
No,
Okay then.
pretty sure I know the answer. But Gary knows the answer, so I.
Actually, I don't. I have this last year. You think it's the whole thing? Okay,
But I could be wrong.
yeah, I'm not sure. Let's see, so that's double that.
It is
You need my laser cut.
Oh, yeah, we can build it.
You could. It's at home.
Is it?
No one.
Like 25 pi over 2.
Listen,
I don't
so I
think
guess
that
we call
helps.
that 25. Minus 1,
Over 2.
2. And that's just this one.
It's 2/3 of the circle.
It's 2/3 of the
I
circle.
think it's 2/3 of the circle.
Okay, so
Oh, no. Yes, it is. I do.
distribute that.
Oh, okay. Okay, hold on, I think I. Right there, and the sections are equal, right?
So the circle,
We're making the assumption that each section is equal.
they are the same size despite my artistic rendering.
Okay.
So back to the computer generated version. All right, so let me see, I'm on the verge of an answer. The answer I think is, there might be an easier way to do this.
Would it be easier to find the not shaded?
That's what I've been doing, yes. I've been focusing on the not shaded region, yeah.
So here is my theory from drawing it.
Yeah.
That, so like, just look at half of it. There's a half circle with 2 sections shaded out of it.
So a half circle, so cut through here diagonally, or
No, like,
you want to come draw?
yeah.
Oh, I think I know.
Go back to the other page I can show you.
Okay.
I think I got it.
I think you got it.
So like, consider this half circle here.
Okay.
And so I
So
am theorizing
let me
that,
catch up to you here. So we consider this half circle here.
yeah,
Okay.
I am theorizing that 2/3 of that space is shaded.
Okay. So
I got another idea.
Just because it was cut from the
All
center
right,
and
so-
went to the
so
edge
take
of
your
the same
idea.
degree.
take your idea and come up with a number and we'll compare numbers.
Can I try
Because
it?
we're almost out of time.
I think I got it.
You want to draw it
I don't
there?
know if
I don't care, I can tell you how I did it.
You got a
Oh, wait,
number?
I can.
Yeah, I even got a number.
What's your number?
Okay, so I got a single number. Ready for this?
Yes.
I think that each individual, so if we split that into see that shaded region we're gonna take out, right
Yeah,
there?
this right here.
Yeah, I think it's 5.3.
You think that's 5.3?
That's 5.3.
Okay, let me see.
R squared.
Is that what I got? That single shaded
That
region.
area?
Just the one
That's
shaded
pi R
region.
squared.
Okay, is,
So negative
I could be wrong. I mean, it's fine, it's possible. I was wrong.
2/3.
what'd you say you got?
5.3.
5.365 maybe?
Yeah.
Oh, that's
Yeah.
what I got too.
Woo! Hey.
All right, so Sarah and I are in agreement about the area, that red shaded area right here. It's about 5.4-ish, if you round properly.
Yeah. My rounding
She's
is
having
off
rounding
today. I'm having rounding
Yes.
issues today.
Okay, so what, did you have a number, Jackie?
I got like the area if like there was a whole circle, so I'm saying, so if you were to take this section, like, I don't know if I can draw it, but if you take these 2 sections and like move them up and take these 2 and move them down, I don't know if that, it would move these sections into the middle. And so my idea, my theory is that that circle,
Yeah.
find the area of that circle, and then 2/3 of that area is the shaded area. But I could be wrong.
Okay, so take that idea and turn it into a number.
Okay, so if my
So
number
I'm
is
about-
78,
So I'm about to come up with a number here, let's see.
if my area is 78, then you find 2/3 of that. So then I take 70 66%.
Clear.
All right, so I believe that the total area is just a hair over 57 units, square units.
I got 52.
Whoops, cool.
I got the same as you. Just a
57
hair
-ish.
over 57, yeah.
Okay, so
Like
let's take a look.
57.1 if we round.
There are many strategies to solve this, and I haven't even thought of half of them, I'm sure, and there's probably more than that. So I'm gonna focus on just this region right here. Yeah, so that region right there, I was sketching out in this page right here. So if I take, let's see, I'm gonna have to, I guess I'm gonna have to start over. Wrong way. Yes, okay, so I'm just focusing on that top square. So I have what is this thing called again? This is a
Quarter circle.
Quarter circle, right? Okay. That's a quarter circle from a radius of 5, true?
Yes,
And I'm removing that from this square.
yes,
Which is bigger, the quarter circle or the square?
the square.
Okay. So then this white area right there has got to be the square minus the quarter circle. True?
Yes.
Okay, what's the area of the square?
25.
What's the area of the quarter circle?
Pi 25 over 4.
Yeah, pi r squared, so that's pi times 25 divided by 4. Okay, so whip out a calculator and calculate 25 minus pi times 25 over 4. That is this white area right there, which I don't want in my figure. What does that come out to be?
5.4.
Sarah? Calculator? What is pi, 25 minus pi times 25 over 4? You can just type it exactly as you see it there. 25 minus pi times 25 divided by 4.
19 and 63. 19.
See? We need 25 minus that. So we go 25 minus that answer. So take 25. Okay, so you did it backwards, so you get a negative number, but yeah, so it's about 5.4.
Yeah.
So this is about 5.4 when you round it to the nearest 10. Okay, how many of those white regions live here? Well, let's see.
7, 8.
There's 1, 2, 3, 4, 5, 6, 7, 8 of them. What's the area of the whole thing? The whole square? 10 by 10?
100.
Yeah. So what we want to do is take 100 and minus 8 of those white regions. And that gives us whatever's left has to be the area we want, the shaded region. So what was the point of this? Well, sometimes it's easier to find area by adding things up. Other times it's easier to find area by taking things away. So we have two different strategies. Sometimes we have to employ both strategies together to try to find a complex region. Is there any one best way to do it? Definitely not. Okay, we are at time for fun with math. That was a hell of an exploration. We didn't get to do much with the Pythagorean theorem today, just a tiny little bit. I did post some homework if you're bored on the Pythagorean theorem. We will look at it next time in more detail. We're going to construct the Pythagorean theorem out of paper triangles.
Really?
Yes, it's cool.
That sounds entertaining.
It is very entertaining.